Hi, this is Shannon Lietz. I am here with the Software Summit, and I'm going to talk to us a bit about breaking into DevSecOps, a maturity story. I've been talking about DevSecOps for a really long time in my career. I'm super passionate about this space, and I really think this is such a big deal for us as a community. So, quick shout out a little bit about me. I have been in this industry for a really long time, since the 1980s. Kind of what makes me human is to basically work with my little girls on STEM, and they're a bunch of ballet. And I like to do comic strips on the side. I also like to do kickboxing, so I'm super into those things. I also spend my days with the DevSecOps Foundation, a lot of the folks out there. My day job, I work for Adobe. I'm excited to be there. I just joined about 8 months ago. And I also help with IONS and Hacker Girl, which is something to bring cybersecurity to more women. So I'm going to start my story with a blank slide for a minute. And I'm going to tell you that one of the things I really deeply appreciate is the learning life cycle, and the DevOps community has always been such a great place for me to participate because I would say, lifelong learner is the way to think about me. So, when learning starts with awareness, it builds upon understanding. You gain folks when they get to commitment, and ultimately that turns into operations or actions. And I like to say that all things that we're doing cultural wise and the things that we're trying to tackle, the hard problems in the world, really get solved through this algorithm. So if you're not aware of it, I would say go look up some of the work that Stanford does, because building out your strategies really does require some change management. And I believe that's kind of at the essence of cultural development. So I'm going to go back to and think about for a moment, hindsight is essentially 2020. Well, not really. Hindsight turns out to be 2022 for me right now. And I think, we've all been through the pandemic, endemic. And I think we're starting to get to the point where we realize some of the ways that we work together can be done more digitally, can be done more natively. And I think some of that is brought to bear because of storytelling. So I'm going to start this keynote off with the fact that I'm going to tell a bit of story, and then I'm going to walk you through a little bit of what it takes to do the maturity journey for DevSecOps. I've been working in this space for over a decade, particularly around DevSecOps and what it really takes to bring to bear. I would say I've been a keen fan of DevOps for a really long time, and Agile as well. So you can see, like, a lot of my career has really been around more of the emerging change management space, and I'm super excited about it. So, if I go way, way, way back in my story to where all things sort of started, I would say computers really kind of came to bear because scaling computation is challenging. Imagine for a moment, I have two little girls who work in kind of mathematics every day, and the new math that's out there is a bit challenging for some of us that learned it the old way. So I'm sure you can relate to that if you have children that are in school right now and trying to figure things out. For me, I think that the essence of this lesson is that because scaling computation is challenging, it created this need, this emergence in humanity to get to the point where more of what we were doing was compute driven. And I think that started really early, several hundred years ago, around how you actually calculated things. In particular, one of the change periods that I like most is when the mainframe came to bear. And I think that this was really interesting because, this picture is depicting what it took to really run compute back when. And hardware was really room size. So you really needed a really large place to do this work. It was really about centralized processing, integrated compute and storage. And then for some, they remember ticker tapes and punch cards, and it was really instruction based. And essentially, your programs were time sharing on this equipment because it was so large, so expensive, and so challenging to master. And really, it was unfriendly. I would say computers came with humans had to learn their language, and not necessarily that computers had to learn the human language. And I think that this is really what we're at the forefront of a lot of the things that we once thought around computing becoming really changed in the industry. So this is at the basis of my story. And I would say that with mainframes, the adversaries out there, in particular, the way you thought about security started with the unskilled programmer. And then as part of designing for a mainframe security, you wanted to be able to figure out when you might have human error. So you built up some of the things that are built into native mainframes and their operating systems. So you had things like RACF around how do you actually deal with finding these things, making sure that they go away. It was non-trivial to fix computer programs back then. So having some of that instrumentation was really critical to making the hardware effective and being able to service all the needs for it. And there was a third here, which was mostly espionage. So you had a few adversary types that traditional mainframes had to solve for. And for me, the beginning of all security goes back to, well, why did we need to do it? And when did we need to do it? And for what purpose? And these three security drivers, I think, really brought to bear a mainframe that solved for its hardware, its security paradigm, its programming requirements. And essentially, as humans, we had to learn all those things so that we could be good at running these really big machines to help us with transactional compute. Imagine for a moment, like the census really did benefit from some of this work. And if you look back, encryption and some of the things that were done during the wars, a lot of those were a lot of the drivers for compute back when, which is why you see these three main adversary types really at the forefront of the story. And if I kind of look past this, you kind of think about what did it take to create security for a mainframe? And I go back to the security hierarchy of needs, something that I've worked with many people to introduce in the industry and that I leverage as part of my way of making security accessible and memorable for folks and really turning it into pearls. And so for me, these 5 things are at the heart of what it takes to get a mainframe set up for security. They had things like logging and audit trails. Encryption was very much baked in. You had some of the authentication through things like I said, RACF and asset management. You really couldn't lose a building-sized computer very easily, and the components in it had to be mastered. A lot of the compute infrastructure was very much hardware-based. And zoning and containment was done through the computer living in the building and what it could reasonably be located next to be able to do compute. So you had a really limited security infrastructure need at that bottom of the pyramid, which meant that really essentially mainframes did solve for a lot of need, and they made it very easy to do some of these client-server native use cases. I like to start this also off with a Wordly map kind of esque discussion, because I think that really at the forefront of mainframes, you saw a few use cases kind of start to create that genesis. The change management went into making it so you could have custom built mainframe level computers. And essentially, eventually that created an entire industry of companies that were starting to be able to make these more cost efficient. And so the product, looked like it was going to do relatively well. Up until we started realizing that the use cases were going to go way up. And we actually found that because we had to build room-sized things and the use cases could go up for compute, that created a bit of that demand curve. And ultimately, this was around a 200-year plus generation or synthesis of calculation and compute. This essentially led us to having hardware be created so that end users could essentially use that hardware and that software. And so within this infrastructure being broken down from a mainframe, essentially hardware being divided from software allowed it to be maybe even more distributed in terms of compute. And so hardware for every human, having an individual being able to have maybe even a computer in their own household was something that was a mere dream at the time. And I think that started to create a little bit of a radical transformation where we were starting to see innovation happening to take huge computer hardware and turn it into something that could ultimately be shipped out to a household and then serviced by software providers in those big buildings that you see here. So that led to essentially what I like to say is a demand curve shift. And so, because there was demand and there was this need for computers, ultimately what happened is the genesis that took place during when people found that mainframes could be useful actually became the next wave of what would ultimately overtake the mainframe as being the potential for compute throughout the industry. And so, this genesis work that was done was around the 1970s, 1980s. You can see that a lot of the work that was out there that generated the computers that we now call our individual computers, and even getting to the point where you have a cell phone and things like that, was really done to figure out how to make computers more useful for humans. And essentially, instead of training humans to speak computer, we were now seeing the possibility of what computers could do for us, and maybe even start to think about how we could make it so that we could write more software as a community and we could distribute that functionality. That gives you the ability to reach more use cases, essentially. So with that, we also saw the creation shortly thereafter of the internet. And that was an interesting time period because now you had essentially hardware which had software on it, and then protocols to create the ability for software that might be housed in companies behind four walls. I like to kind of create the whole jail picture here, because we essentially put our software in jail, is the way I like to think about that revolution, because we put huge hosting providers together. They had essentially racks of equipment and they were all caged. And so we were essentially building up software that could be accessed for distributed compute. There were protocols to make it so that we could exchange information more rationally. And during this period, we saw a lot of innovation. I remember back when the dot-com boom happened, and some of those things that really traditionally led us to some of the evolution that inspired us as a community. And that led to a bit of what I say got me into a lot of this next journey. And I think it's really that Waterfall, Agile, DevOps movement. We were starting to realize we weren't moving as fast as we wanted to as a community to get to customer use cases. We weren't as creative as we wanted to be. And so for me, I've always been a creative type. I've always moved closer and closer to that innovation space, that emerging space, always moved to the next thing because I really want to be at that forefront of creation and design. And for me, that has led to an inspiration of how do you help folks to be able to do that change management? How do you think ahead, have dreams? And culture is the most important aspect to DevOps, succeeding in the enterprise. I love when Patrick Dubois said this, because for me, it's an inspiration to see that at the heart of all of this, we've really been liberating compute capabilities for a lot of the folks that are out there to leverage it in their daily lives. We wouldn't have AI ML, we wouldn't have some of the voice-enabled services without some of these demands and these use cases coming up. So it's been traditionally a big drive. I think the developer revolt's really real because you see that ultimately what drives the developers that they want to create something very useful for the customers that they might have. And that creates a great drive for a lot of this change. And with that, new models. For anybody who remembers back the OSI model, and for anybody who works with some of the cloud providers out there, they still have to know the OSI model. They still have to be able to create those infrastructures and liberate software. And essentially, this is the liberation of software. Everything has become software defined. We've made it so hardware no longer we have to speak its language, but it speaks our language. And that has created some of the ability for us to do some of those next generation things. And the cloud being born from that. Software not only being able to speak the language of a human, but being able to now exchange and do interface-based compute. You still have your hardware and your software capabilities in your house. That has been a mainstay, but some of the evolution to how we actually interchange and distribute computing so we can solve huge problems across the world has become liberated through the cloud and some of these APIs and really SaaS-based services or IaaS or even PaaS services. They've really allowed us to exchange as a community and create more and more innovation that's going to be higher speeds. And I think these are really the tenets of what begins this story. And if you remember back to when I said these were the three original adversary types that were conceived when we got into essentially electronic-based compute, today's generation and all of that innovation has left behind quite a bit of the security task. While engineering teams are busy deploying leading edge technologies, security teams are still focused on fighting yesterday's battles. I totally believe in the survey that was generated. You still see a lot of this today. Folks are still trying to figure out how they're going to put security to the forefront, shift it left, figure out what to do with it. And that's been at the basis of my work. I like to think that if we had done this well, we would have had maybe the same or fewer of those three circles originally, but really what's generated a lot more capability for the adversary communities is the change management of distributed computing. And so this has given rise to a lot more adversary types. I wowould say those categories of adversaries now have abuse capabilities at their disposal. They're leveraging some of the same platforms we all are. And it has created really that rallying cry for change. For me, that has turned it into essentially a bit of like 2016 going back a bit for me. What really spurred me on was to see that this traditional compute infrastructure, everything was changing. There was a demand by the customer to have more and more capability at their disposal. Mobile was becoming a thing. And if you look further out, really security has had to change, and it has been on the emerging front for quite some time. So this is a 2016 slide. I've got some from recent, and I'll definitely share in that space as we go on. I think that this leads to what is next, and what is ultimately next is trying to figure out all these patterns that are going to come from this. 2014 ultimately, before even sharing that Wordly map, led to a bit of, hey, things are changing. We need to do better as a security community. And the inspiration was really this manifesto. We sat down and said, we need to lean in over saying, no, a lot of the things on this have still been true. And I think we are as a community trying to get to the point where we are more left than right on this list of things that we've put together. I really think that getting rid of fear, uncertainty, doubt is a mainstay. So let's talk about levels, because everybody wants to know how they're going to get started and then how they're going to get to the point where they mature and how can they be level 5, because everybody wants to have that gold star at the end. And ultimately, I'd tell you it's a journey. And a lot of the journey for me in terms of telling the story started in 2014. While it still started a bit earlier than that, I don't think I had a lot of the understanding truly of being able to tell the story to others until I had done a bunch of experimentation. This is some of the initial work that was done to put the experiments in place as we were working on things like migrating as a community to the cloud and AWS and Azure and Google and all of these different providers out there. I think that's necessary to create those drivers for change to happen. And embedding into DevOps really didn't work. It was quite a disaster. There was a lot that was happening at the time. And really, security professionals couldn't just bring their checklist, pop down in the middle of a development team, and get to work. They had to have development skills. And so that meant all of us had to have development skills. We had to figure out the art of DevSecOps. We had to get to the point where we could get more of this figured out in a way that would make it consumable for our peers and partners. In level 2, DevOps growth was off the charts. In 2004, DevOps.com was bought. And you could see that it took quite some time for it to evolve. And now we're even in a faster part of this life cycle. In 2015, for me, what it felt like was security engineering was relatively new. There wasn't this thing called compliance operations, or what people now call policy as code. Security wasn't code at the time, and there wasn't this thing called security science. You really just didn't have data at your disposal. It wasn't cheap enough. And so thankfully, the clouds have all created those capabilities. Imagine adding security into your DevOps pipeline. This is a lot of what it looked like. Your business business, your UX, your dev, your data. A lot of people say things like dev star ops, because there's a lot of different things that have to come into this discipline. And really, security self-service required a lot of these things and these skills to be able to be brought to bear for operational people to take advantage of, and the business, and some of the folks that are creating software, and as well as our customers. I think level 3, shortly thereafter, it was an innovation idea, was to look around and see what other enterprises were doing, and be inspired by them, and as well as trying to figure out what was working in the industry. Where were we seeing some of these build security in, or build safety in? And you look at like the Edwards Deming process. And I think that supply chain is really at the essence of creating that faster security feedback loop, where you design, you build, you deploy, and you operate. But really, that security feedback loop has to go back to design. It has to be and is a needed constraint for you to build better and safer things over time. So the better and safer things turns into, well, traditional security is really just not going to work long term. And so what had to happen in the relative to 2016 timeframe for me was security was everyone's responsibility. You couldn't just have silos of it. It wasn't somebody else that you could shuttle it off to and it was going to be fine. In fact, those processes were just not working. And now that it is everyone's responsibility, I still think that generates a lot of demand and need for change. In fact, new things like new innovations that have to happen. But I still believe that those innovations come back to these 5 tenets, and the 5 tenets are pretty simple. They've created a lot of the disciplines that we have out there, the things that we know work against the abuse cases or adversary cases that are out there. So keeping it kind of straight, having a model to work from, allows you to advance your maturity and your capability. And I think it's really critical to have something to tie to, so that as you're testing, as you're trying to make change happen, as you're designing things, these core 5 things can actually reduce about 80% of the abuse cases out there. And again, I think that really DevSecOps is not just about getting software safe and perfect, but it's also making it adversary resilient. So somewhere in this time frame, I really became very adversary minded in my approach. With the things that I was leading and changing and experimenting with. And the automated testing and inspection pipeline. We talk about DevSecOps as if it is mostly about the CI/CD pipeline. And I would say that's a bit of a miss in the industry. We really have to think about the ability to leverage the CI/CD pipeline to bring security closer and closer to developed software. But you'll also find that developed software is now a fabric and a distribution that does need to be continually tested, not only as part of construction, but as part of basically deployment as well. So a lot of the work that you do is to make software as safe as possible for what it's intended to do, and then to look for those edge cases. And so some of these CI/CD pipelines have to also include this continuous notion of feedback and a security testing and data platform. This is not the best picture I've ever generated, but it's absolutely one that you can see helps you to understand that the attacker's out there and they're sort of leveraging that same pipeline that a customer is leveraging. And we can get more information as a community. We can have things like security observability. I've been telling this story for a really long time because we are not seeing the advancements quite that we need to get more and more of the security capabilities built in. I think we're still in this custom built part of this journey. There are some folks out there that are starting to make headway. We are seeing that commercialization of DevSecOps, and we have done a great job, I think, in trying to advance it as a cause. And I think that we're starting to make strides in a way that allows it to be commoditized, but that we have missed some of the things that make it so that you get that full understanding of DevSecOps. It's really that adversary notion. That creates a lot of the demand for, what are attackers doing? What are those pathways? How do we solve for those? How do developers understand what they are as part of the things that they can generate? And as you create new features, how could those be abused in a way that you actually have to be mindful about? In 2016, we knew these things. We had a lot of understanding about them. And it created a sense of, well, what's the next thing we have to solve for if we know about these things? We've got to have this understanding of what it means. It should feel like we're actually continually improving. And so we put this behavior chart together to figure out how to essentially, in the end, stay ahead of bad guys and have that adversary resilience really be your fly mechanism. If you're doing CI/CD, I'd say you can get to a point where you're being more proactive, but you're probably still in between levels 2 and 3 in reality. If you're not measurement bound, if you're not doing OKRs, if you're not subscribing to some of these measurement practices, it can be a bit challenging. So one of the things that I learned along the way was, hey, when you get some of the information out of these systems and you essentially pull down the information and the features and the defects, you can grade these things, and that can make it more accessible ultimately for developers. There's a large body of context in the security community, whether it be the work being done by MITRE or the kill chain or any of the things that are now trying to create some semblance of a discipline that can be measured. You have to have some of these rubrics to be able to determine, are we doing the things that everybody else is doing? So you do have to have them. But because they are so challenging and they do require a lot of context, they do require you to create a bit of an accessibility layer for people to leverage the security mindset and capabilities of professionals and experts. I think that really that leads to the fact that in 1976, essentially security in my mind was left out of some critical papers for quality. And these critical papers for quality created a bit of this notion that security, like how we were doing mainframes, was essentially an integrity problem. And you can see in here in the very middle there, it says integrity. Is it secure? And these critical software factors that were out there for quality led to how we were going to test software, how we were going to decide it was great and okay. And that created several decades of this is what it takes to have quality software. And I think that we kind of didn't get what we needed to out of that. So what I've worked on and introduced in my research with a lot of folks out there is this notion of securability, having our quest for reducing exploitable opportunities, whether it be shift left in your CI/CD pipeline pre-deployment, or it be they got out of the gate and you didn't know how they were going to be exploited, or something that was really unknown at the time, or even the deterioration of software being exposed. I think that this measurement has really helped me to ground myself in what it means to do great things with software and having software safer sooner. At the basis of that, having a measurement is what leads you to that level 5 and being able to do continuous integration of security and being able to monitor for it and making sure that you've got all of the security things that you need in your software and that you've got your abuse cases mastered so that you understand that you're providing the best view of your software for your developed customer, and over time reducing more and more the adversaries and the abuse cases in your software. This has led to a lot of innovation, but ultimately I would say we are all now basically scratching at the surface of the software bill of materials, because the large demand here is, now that we know how we can measure some of the security that's out there, it is not only the component parts that we all build individually, but it's the ones that we actually snap together that creates the fabric of distributed computing. And so now it's going to require us to be able to share information, to synthesize it in a way that it's accessible without necessarily having to divulge all these different things about what software is. A developer always asks, how many lines of code do they have to really worry about? And I always say, are you sure you only have a few lines of code? Is it really only a few lines of code? And I did a study here. I actually talked to a few folks, and Snick, thank you for this example. But 222 lines of code has turned into essentially 5 direct dependencies, 54 total dependencies, and that can easily mean that a very small program can still be hundreds of thousands of lines of code that we know through practice cannot actually be dealt with and innovation driven forward without automation to help reduce the potential for these critical security vulnerabilities that get created in ways that we don't expect. So I would say, ultimately at the beginning of the forefront of continuous integration is this need for software bill of materials. And I always say that when you find something hard to work on, it's worth banging your head. And I tend to be a big believer that finding hard challenges and working on them will actually allow us to move forward as a community faster. So my work has really helped to figure out, what does it mean to bang your head on this problem, the software bill of materials. OWASP does a great job of enumerating some of the defects in software to help us as a community. I will tell you, though, you need to actually leverage observability against this discipline that's being created by OWASP so you can understand your own adversaries and understand what they're doing. Because you can see here that researchers do certain things, scanners can do a bunch of other things. You might even see paid noise by your adversaries. And ultimately, that allows advanced adversaries to move forward with things that you never intended to be part of your software stack. So to me, continuous improvement is about less guessing, more real world, more observability. And I think ultimately, in the end, simplifying everything. I go back to what I believe really has helped my understanding of software becoming safer become a critical part of what I do every day. And that is the security hierarchy of needs. And I think that, I always carry this cat with me to every one of my talks because ultimately it's the skeptical cat. It's the one that keeps me thinking about the future, really trying to understand it, driving me forward as a researcher. I will tell you, this is my next generation of that same Wardley map. And ultimately, I think we're all chasing the next generation of compute, which leads us to more AI, ML. And the future is really anyone's guess. But for me, this is my guess. So, to inspire you to think about what we could be doing together, I think that it's really important for us to understand that at the heart of all AI, ML, there is a security challenge at our forefront, and that we want to be able to do more things as humans. We have to solve for it. So thank you for listening to me today. Here's some books that I really think are amazing. I'm a big proponent for some of the folks that have written these books and taken the time to educate us on things like DevOps and accelerating our capabilities and thinking about security. So if you get a chance, I would definitely inspire you to read some of these. Thank you.